Okay, everyone, this is 6.6, which is our very last lesson for the course. So that's very exciting. And it's related to yesterday's lesson where we were making the graphs, but now we're kind of going backwards. So we have the graph, and now we're going to answer questions with regards to it. Okay, so Tim has a model train that goes around a circular track, and Tim is standing directly south of the track. Okay, so if you had a track and a train going around it, so it looks something like this. Okay, and if you're standing here, okay, so what happens is the train is close to you here, and as it's going around, the distance is getting further away from you, and then closer to you, and then further away. So that's what this represents. So the train is close to you, far away, comes back close to you, goes back far away, back close to you, and so on. Okay, so first one, what is the equation of the axis? What is the equation of the axis of the function? Okay, so I gave you the formula yesterday. It is the maximum plus the minimum divided by 2. So our maximum height here is 4.5. And our lowest value is 0.5. So add them together, you get 5. Divided by 2 gives you 2.5 meters. So at 2.5 meters, we have our equation of the axis. Okay, so that's the middle of the graph of the sinusoidal wave. So that means there's an equal spaces above and below that point. So your maximum should be the equal distance from the equation of the axis as your minimum value. Okay, so let me see. 1, 2, 3, 4. 1, 2, 3, 4. Good. What is the amplitude of the function? Oops. So the amplitude of the function is the distance from the equation of the axis up to the highest point. So if you measure from here to here, so we go from 2.5 to 4.5, it is 2 meters. Okay. Likewise, you can go the equation of the axis down to the lowest point. So from 2.5 to 1/2 is still 2 meters. Okay, what is the period of the function and what does it represent in this situation? Okay, so the period is how long does it take to make one cycle? So if we go from here, we go up and we go down, and then after we hit this point, it repeats itself. Okay, so from here to here is 30 seconds. So 30 seconds is the cycle, 30 seconds, and this represents how long it takes for the train to go around once. I apologize for the dogs barking in the background. How long it takes for the train to make one revolution or one lap. Okay, what is the range of the function? So we're looking at our y values. So our range, y-e-r. Okay, so our range is what y values we have. So we have from 0.5 up to 4.5. So y is greater than or equal to 0.5, but less than or equal to 4.5. Okay, now we're going to determine the equation. I apologize for the shadows as well in this video. Okay, so the equation. So we have f at x, or y, equals a sine k x minus d plus c. So let's plug in some values that we know. Well, we already found the a value, which was the amplitude, so it's 2. Okay, the k value we need to find, so k value is 360 divided by the period. So we have 360 divided by the period, which is 30. So that gives you 12. Okay, so we have 12 as our k value. Or what else I would also take, so if we're working in radians, it should be 2 pi divided by 30, which is pi over 15. So actually that's the real way. Sorry, convert this is in degrees, convert it to radians, so my apologies. So it should be pi over 15. Okay, so 360 is degrees, but 2 pi is the same as 360. Divided by 30, if you just reduce this, so 2 over 30 is the same as 1 over 15, so pi over 15. Okay, so then we notice that it starts at the lowest value. Okay, it doesn't start anywhere in between them, so we don't have a shift left or right. So our d value is 0, so we don't need to write it. And now our c value is the equation of the axis, which we determined already to be 2.5. Okay, so just to simplify this further, so it's just 2 sine pi over 15x plus 2.5. Okay, we don't have a d value, so we don't need to have our brackets. So that's our a, our k, and our c. Okay, but I want to notice one thing. So we are starting at the lowest value. Oh, I made a mistake here. This shouldn't be sine. Sorry, I'm going to correct 2 things. Okay, so it starts at our lowest value. It doesn't start at the equation of the axis. It starts at our lowest value. If it started at the equation of the axis, so say it started here and then went up and down, then it would be a sine. But since it started at either the highest or lowest value, it then becomes cos. So we have cos here. And then a positive cos starts at the highest value, but a negative cos starts at the lowest value. So what we have here is negative 2 cos pi over 15x plus 2.5. And then that, sorry, I'm just trying to hold this. So negative 2, so negative because it starts at the lowest value. Since it starts at one of the maximum, it's cos. Pi over 15 is your k value, and 2.5 is the equation of the axis. Okay, it didn't specify anything about variables, but this would be t, this would be your time, and the f and x would be your height, sorry, your distance. Okay, lastly, what is the train's distance north of Tim at 52 seconds, round to the nearest hundredth of a meter? So it'll be negative 2 cos pi over 15 times 52 plus 2.5. Okay, I seem to forget my calculator downstairs. So what I would do is multiply these together. So 52. If you want to change this into degrees, so you go 52 times 180 over 15 plus 2.5. So do negative 2 times cos of this. So do cos of this first times negative 2 plus 2.5, and you'll get your answer there. Okay, since I don't have my calculator with me, I can't do it. So what I'll do is I will email you guys the final answer for that question. Okay, so that is the last lesson of the course. Okay, chapter 6.6, and I'll see you guys in the afternoon. Take care. Bye.